I am architect Archana Agarwal. This is part 3 of my video series on site visit and site analysis by an architect. The architect's role in the site visit is divided under 3 phases. That is, before visiting the site, during the site visit, and after the site visit. The first 2 stages have been explained in the previous parts of this video series. In this video, I will be covering the various parameters to be considered while doing the site analysis after visiting the site. This is an overview of the entire process. Before visiting the site, an architect collects site-specific information either from the client or from the internet. Architect identifies the information needed from the site, prepares a list of questions to be asked at site, determines if it is necessary to enter any restricted area and arranges for the permission, makes a team that is required to visit the site and plans the site visit. A data gathering template comes very handy at the site where questions are written on the paper and there is space to write the corresponding answers. During the site visit, the architect identifies the possible source areas, looks for signs of human activities, asks the questions as per the questionnaire prepared, collects the documents and data as per the list, takes the photographs, records the physical features, and meets with the community as well as the local office. And then documents the site visit findings. After the site visit, the architect reviews, compiles, and evaluates the site visit, analyzes the site data to establish design parameters leading to the design solutions, identifies any further data needs and takes action accordingly, performs further site analysis if required, and then prepares a site visit report if needed for future reference. What is site analysis? Architectural site analysis is the process of researching and analyzing the social, historical, climatic, geographical, legal, and infrastructural characteristics of a given site and synthesizing these analyses into visual information, usually in the form of site analysis diagrams. The examination of these characteristics in conjunction with the project requirements are the foundation for making informed decisions throughout the design process. What is the importance of site analysis? Why should an architect carry out site analysis? The main purpose is to establish parameters to implement the best design that responds to the physical and environmental features of the site. The objective of contextual analysis that looks at the existing conditions of a project site along with any imminent or potential future conditions is to inform about a site prior to the start of the design process so that the initial design thinking about a site can incorporate considered responses to the external conditions. An architectural site analysis looks at issues such as site location, size, topography, zoning, traffic conditions, and climate. The analysis also needs to consider any future developments or changes to the site surroundings, such as a change of road designations, changing cultural patterns, or other significant building developments within the area. Understanding the site context is very important for an architect to make informed decision about the design development. Further, the site analysis by the team helps in assessing whether development is financially feasible and whether construction on the site is viable. The site analysis begins with reviewing and compiling the data and all the study that is done. The architects devise different methods and formats for doing this. I am presenting my method of collating the data. I have divided the data collection into 5 categories and the study done into 6 categories. Under location, I have the address of the site, coordinates, and distance from the nearest airport or railway station. Site features include size, shape, dimension of the site, orientation with respect to north, boundary wall, access to the site, topography, that is contours, and the soil condition, and the SBC, that is safe bearing capacity of the soil, groundwater level, trees and vegetation, existing structures on the site, existing utilities or services lines within the site, and the microclimate of the site. The data related to surroundings includes the roads and pathways around the site, defining the accessibility to the site, the neighboring buildings, their configuration, style, age, condition, the type of roof, sunshades, fenestration, materials used, parking, the greenery around the site, use of solar panels or windmills, traffic patterns of vehicular and pedestrian, the culture of the area, safety and security of the area, history of the area, ecological diversity, the political scene if necessary, general lifestyle, whether the area comes under smart city or under any government scheme, the levels of the roads and the surroundings, is there a proper access to the site for construction purpose, and then the geographical features like nearby water bodies or hills, and the street lights. Next is checking the availability of various utilities and services like water supply, drainage, sewerage, gas pipeline, internet, and telephone. Also checking from the nearest electrical substation, water tank, and sewage treatment plant whether the capacity is sufficient to take the load of our proposed project. The current condition of site includes data like waterlogging or flooding on the site, any encroachment, if any fire has happened recently, pollution, land pollution, air pollution, water pollution, noise pollution, or any odor. And then all the study done is compiled under 6 heads. First is the study of project requirements, which includes the project brief received from the client, the area requirements, and the briefing from the client. Study of statutory regulations and data includes the study of land use map, development plan, applicable FSI, ground coverage, height restrictions, marginal spaces, and recreation ground, requirement of amenity space, consideration for road widening, and if applicable, the rules such as CRZ, aviation, highways, greenbelt, and heritage. The climate study includes the type of climate, sun path, wind direction, temperature and rain throughout the year, and microclimate. Study of applicable sustainable practices includes tree cutting regulations, noise regulations, energy optimization, water management, waste management, building materials, and occupant comfort. The other study done about the site and its surroundings includes history and culture of the place, ecological diversity, political scene, whether in smart city, whether part of a government scheme, local materials, vernacular architecture, seismic zone, future development around the site, change in road designations, change in traffic patterns, or change in cultural patterns due to any upcoming project, and locally available resources. And then is the compilation and study of the data obtained while doing the survey at site through interviews and questionnaires, gathering the opinion of the people. The data collected would be in various formats: text format, photographs, Google Maps, aerial images, tables, graphs, sketches, audio, or video. This data needs to be evaluated and modified for the purpose of analysis and presentation of site analysis. The data needs to be synthesized based on the mode of submission or presentation. The submittals may be in the form of a report or a drawing sheet or a PowerPoint presentation. If the submission is in the form of a report, then more text is required, which has to be written down in a particular format. One sample of the contents of the report is shown on the screen. While the report has to be self-explanatory, the same is not the case if the submission has to be done in the form of a drawing sheet or in the form of a PowerPoint presentation. A narrative has to be prepared for explaining the sheet or the presentation. The sheets can be composed in many ways as shown on the screen. However, if the site analysis has to be presented in a PowerPoint format, then many more pictures can be added and videos also can be added. The presentation of the site analysis begins with the location map. The coordinates of the site are written and distances from all places of importance are also mentioned. Image from Google Maps or Google Earth is shown with the site marked to give more clarity about the location. Satellite view as well as the terrain view can be shown. Analysis gives an idea to the designer whether the site falls under hilly area, plateau, plains, or valley, whether it's a prime area close to airport or railway station, or is it a remote area, whether the surroundings on the map are showing it as a developed area or as a developing area. The data related to the site features collected from the internet or during the site visit is represented in the form of text, graphics, pictures, sketches, and photographs. The site photographs are shown with the view angles marked on the site plan. Location appraisal and site appraisal may be written down, highlighting the important factors which will influence the design. To the scale drafted site plan with dimensions and north direction is shown. Roads abutting the site or adjacent to the site are shown. Geotechnical data extracted from the report or from Google Maps is briefly described. Current condition of the site, including visual elements as well as sensory elements, should be depicted in text form or graphical form, which may include videos, pictures, sketches, etc. Sketches and photographs of boundary wall and gate should be added. Contours should be shown on the site plan. How to extract contours from Google Earth is explained further in this video. Site plan showing existing trees and vegetation along with the names of the trees and plants and the photographs are also represented. Type of soil, SBC of soil, groundwater level should be mentioned. Site section extending up to the access road should be drawn. Existing structures should be depicted in sketch form and photographs and videos. Existing utilities and services lines should be marked on the site plan. If architectural drawing of the existing structure is available, then that is added. Analysis of site features guides an architect on the parameters to be considered while designing, such as hazards to be considered to overcome the current issues, existing trees to be considered to minimize cutting of trees, contours to be considered in design to minimize cutting and filling, existing structures or features to be considered if they are to be retained, the configuration and style of existing structures to be kept in mind while zoning and designing new structures. GIS is the best medium for topographical analysis. The contours on the site can be derived using several methods. The most commonly used methods are using Google Earth, using a drone, or getting the physical survey done through a surveyor. Making contours from Google Earth involves two steps. First, making a KML file, and second, converting KML to DXF. DXF file can be opened in AutoCAD. First and foremost, Google Earth needs to be downloaded and installed on the computer. Zoom in to the area of the location of the site. On the Add Polygon button on the Google Earth toolbar, and by clicking on the corners of the site, make a polygon. Right click to remove the points. The opacity should be set somewhere between 40% to 50%. Most importantly, the altitude tab should be set to relative to ground. This will enable the KML file that you will be creating to be able to be viewed on Google Maps. On the Google Earth toolbar, click on Path. Then on the map, click on each corner of the site in a sequence so as to close the path. Right-click to remove the points. Be sure to set the altitude to relative to ground. This will enable the KML file to be viewed on Google Maps. After the polygon or path is added, right-click on the item in the Places section of the sidebar and choose Save Places As. Select KML in Save as Type drop-down. Name it and click Save. KML file can also be made on a website, Contour Map Creator. KML file or KMZ file created either by using Google Earth or any other website can be converted into a DXF or DWG file to be used in AutoCAD. Global Mapper is very easy to use, and so is My Geodata Converter. For GPS Visualizer, the path created in the Google Earth has to be more dense with more number of lines covering the site. Surveying with a drone offers enormous potential to GIS professionals as well as architects. With a drone, it is possible to carry out topographic surveys of the same quality as the highly accurate measurements collected by traditional methods, but the time can be substantially reduced by using a drone. The cost of site survey and the workload of specialists in the field is also tremendously reduced. During a drone survey, the ground is photographed several times from different angles and each image is tagged with coordinates. Photogrammetry combines images that contain the same point on the ground from multiple vantage points to yield detailed 2D and 3D maps. From this data, a photogrammetry software can create geo-referenced orthomosaics, elevation models, or 3D models of the project area. These maps can also be used to extract information such as highly accurate distances or volumetric measurements. Unlike manned aircraft or satellite imagery, drones can fly at a much lower altitude, making the generation of high-resolution, high-accuracy data much faster, less expensive, and independent of atmospheric conditions such as cloud cover. The output of a drone survey can be a 3D textured mesh, which can be in PDF format or DXF format. Contour lines can also be created in PDF format or SHP format or DXF format. DXF file can be opened in AutoCAD. For more details, refer to the website wingtra.com. For analyzing the surroundings, the location of site on the city map is shown and then the immediate surroundings are shown through a Google image. The character of the neighboring buildings can be represented in various ways. Photographs and videos taken during the site visit should also be added. With respect to the north direction, the sun path and wind direction can be marked. Nearby water bodies, hills, and other geographical features can be shown. Areas surrounding the site, the shopping areas, and other areas of significance can be marked. Sensory features including noise polluting sources and other pollution sources can also be marked. The road connectivity to the site should be clearly shown. Traffic patterns at different times on different days should be shown. The other data can be presented in the form of text, graphs, sketches, pictures, videos, maps, etc. The information that can be included is population of the place, sex ratio, age-wise distribution, history of the place, culture of the place, development of the place over the years, urban versus suburban growth, and future development plans. Any other significant information can also be added. Analysis of the data collected related to surroundings would include aspects such as cultural connections, workday amenities, mobility, density flows, urbanized areas, trees and vegetation, neighboring buildings, land use, traffic patterns, sensory elements, and many more. The sketches made for analyzing the data can also be included in the presentation. GIS is very useful to substantiate the observations, to map them, and to analyze real-time data sets such as geographical, spatial, traffic, population, historic, and climatic. GIS applications include both hardware and software systems. These applications may include cartographic data, photographic data, digital data, or data in spreadsheets. Cartographic data are already in map form and may include such information as the location of rivers, roads, hills, and valleys. Climate data is available on the internet. India Meteorological Department's website and other websites like meteorblue.com provide data related to temperature, wind, rainfall, and humidity. Climate analysis includes solar paths, irradiance, cloud cover, wind rose speed plus gust, temperature, rainfall, psychometric analysis for comfort design strategies. Microclimate is a local atmospheric zone where the climate differs from the surrounding area. The term may refer to areas as small as few square meters or as large as many square kilometers. Microclimates exist near bodies of water which may cool the local atmosphere, or in heavily urban areas where brick, concrete, and asphalt absorb the sun's energy, heat up, and re-radiate that heat to the ambient air, resulting into urban heat island effect. Factors that affect microclimate include topography, soil, water, vegetation, and artificial structures. A range of software and plugins are available for modeling microclimate variables. Commonly used tools include Ladybug, EnviMet, SimScale, and Eddy 3D. Sun path, wind path, and rainfall analysis can be shown in the form of sketches. These are some of the other factors that can be analyzed. Results of the survey carried out during the site visit can be presented here in the form of a pie chart. View and vista analysis can be shown here, highlighting the positive and the negative views. SWOT analysis showing the strength, weakness, opportunities, and threat can also be presented. For designing a project, an architect requires three basic things. First, the design brief from the client or the owner. Second, applicable statutory rules and regulations. And third, the site parameters. As explained in this video series, the information collected from the internet and from the site visit influences the design. And this information includes data regarding surroundings, current and future traffic patterns, future developments in the area, geographic features, history and culture of the place. The site analysis done on the basis of so many parameters enables the architect to make certain conscious decisions regarding the design of the project, such as access points to the site, circulation within the site, zoning of various buildings, orientation of buildings, regulating lines based on the statutory requirements and geographical conditions, location of services and utility lines, decision on diversion of any utility lines, choice of materials for construction and finishing, style of architecture, mitigation measures for pollution, and sustainable architecture. While taking all these design decisions, the various aspects that are kept in mind are rhythm and repetition, hierarchy, space to void relationships, views and aesthetics, health and well-being, response to surroundings, climate and microclimate, daylight quality, shadow patterns, natural ventilation, water management, solid waste management, use of renewable energy, affordability, marketability and value proposition, constructability, type of construction, utilities and services, labor camp, and phasing of construction. This is the end of my video series on site visit and site analysis by an architect. Subscribe to my channel to keep viewing more such educational videos. Thank you.